Lesson 2-7, solving absolute value equations. Now, I think this is really exciting because it's something totally new that you have not covered before, although you've talked about absolute value in the past. So hang in there for this new information. Make sure you've got your notes for page 29 out. And our notes don't fit real well with this page, but we'll do our best to kind of cram them on. You'll definitely need that space at the bottom of the page for examples, and if you run out of room there, you can work up at the top also. So let's get to it. So the first thing is that, of course, absolute value is a number's distance from 0. And we know that the absolute value of 6 is 6 and the absolute value of -6 is 6. And I can actually draw that on a number line. Right. Here's my number line, which is also called a graph. So on your notes where it says graph, you can go ahead and create this little graph. Here's my 0, right? And right, I've got 6 and -6. Those are both, right? That distance on both of them is the absolute value of 6. I'm going to go ahead and write that in a different color. Okay, so either way, right, we get a distance of 6 units. Okay. Now, as we move into equations, what we want to think about is this equation, the absolute value of x equals 6. And in words, this goes in that little box on page 29 where it says words, you're going to write what values of x have an absolute value of 6. That's what that equation is saying. What can I put in here in place of x that when I take its absolute value, I'll get 6? Well, the only things I could put in there that would give me positive 6 after I take the absolute value would be 6 or -6. So I actually have two answers. Okay. Algebraically, right, if it's true for 6, it must be true for a whole bunch of other things too, right? So for any real number a, okay, the absolute value of x equals a means that x either equals a or -a, right? So a or its opposite. So you should now have all 4 of those boxes filled in the kind of the top half there of page 29. So then what we realize, the big aha moment here, is that absolute value equations can have 2 solutions. This is the first time you have solved equations where legitimately there are 2 solutions. Right? And one is based on the positive value for the absolute value, and one is based on the negative value. So a very, very basic absolute value equation, very similar to the one I had on the previous slide. If the absolute value of x equals 8, then x has to equal 8, okay? Right? Or -8. Either one's okay. And on these equations, we actually usually write our answers in braces. Braces are the wiggly brackets, right? And you write them right next to each other with a comma in between. And you'll get better at making them. If you're not very good at making them, you can just make squiggles. Okay. Writing down the steps. There's a box for this on page 29. You'll notice that mine actually has 4 steps, so you'll have to add a 4th one at the bottom. And remember, if I go too fast for you, then you can pause it and finish writing everything down. Right? And I know you're going to have to write small there for box 2. Step 1, you're going to isolate the whole absolute value part of the equation on one side of the equation using inverse operations. So before we do anything to get inside the absolute value bars, we want that stuff all by itself on one side of the equation equal to a number on the other side. Get that absolute value part all by itself. Then you're going to set up 2 equations without the absolute value bars. So as soon as you split it into 2 equations, kind of like this, right? Then you're going to have an equation, and you got another equation, no more absolute value bars. Okay? One equation is equal to the positive value from the other side of the equation. And the second equation is equal to the negative value on the other side of the equation. Right? So let's say we're going to do a real example here in a moment. Let me change colors and I'll fill something in just so this makes a little bit more sense. Right? So if in here was x plus 2, and over here I had 10, then my 2 equations would be x plus 2 equals positive 10, and x plus 2 equals negative 10. Okay. We solve each little equation, same way we always would, and then you write both answers in a set of braces. Notice that the answers are not just the negative and positive of the same number. Don't be sloppy. It happens sometimes. You should be able to figure out when, but it doesn't happen all the time. Let's try another one. Write this one down. You can see if it's all laid out for you already. Okay, I'll talk you through it. Write it down below where you wrote your steps down. Okay, this is very much like the example we just did. So if I have the absolute value of x plus 12 equals 5, my two equations are x plus 12 equals positive 5 and x plus 12 equals negative 5. Notice the equations you have to solve are really nice and easy. Okay, it's one of my favorite things about this lesson. Okay. And then you just do the math for each one. Right? Subtract 12 from each side on both of them. Right? Notice that what I have on the left side is exactly the same each time. Right? It's only what's on the right side that's different. Solve each of them, put your answer in braces. Let's try one that's a little more complicated. I didn't think this was the next example, but we'll go for it. It's not the next example. Let's go back. Okay. When we have the absolute value bars multiplied by a number, we don't want to distribute. We want to get it all alone by dividing. And the reason for that is if that number out front was negative and I multiply it in, it's going to mess everything up. It's going to really change the whole problem. So as tempting as it is to distribute, and I know we often distribute, right? On these problems we're actually going to divide, okay, to get it all by itself. Don't put things into the absolute value bars from outside of them. And then we can go ahead and solve it the same way. Okay, so we've got 2x plus 3 equals 5, and 2x plus 3 equals negative 5. Notice I always write both equations down at the beginning. That way I don't forget about one of them. Solve. 2x is equal negative 8, so x equals negative 4. Or 2x is equal 2, so x equals positive 1. And you can go back and check that, make sure it works. Right? 2 times 1 is 2, plus 3 makes 5. Absolute value of 5 is 5, times 5 makes 25. If you put in negative 4, you get negative 8 plus 3, which is also, right, it's negative 5, but when you take the absolute value of that, you get positive 5, then you multiply it by the 5 on the outside, and we still get 25. Okay, so our answers are right, and we write them down in the braces, positive 1 and negative 4. This time, right, this is the last of these kinds of examples. And you get 15 equals the absolute value of m plus 5 plus 4. Same kind of idea as last time. Don't just take those absolute value bars off and mush the 4 or mush the 4 inside and keep the absolute value bars. You got to get rid of that 4 first. Okay? Don't put stuff into the absolute value bars that wasn't there to start with. So we're going to subtract our 4, and now we have 11 equals the absolute value of m plus 5. Okay? And we write our two equations. 11 equals m plus 5, or negative 11 equals m plus 5. You can turn them around if you prefer to have the m plus 5 on the left. And then just solve each of them. So we get m equals negative 16, or m equals 6. Okay, and you can go back and check those. 11 plus 4 is 15. Negative 11, absolute value is 11, plus 4 also makes 15. Okay, doesn't matter what order your answers go in, by the way. We've got a couple of special cases here. Not quite sure where you're going to cram these in. You might have to get out a piece of binder paper to fit this information in, maybe up top somewhere. Okay, but these are really important to write down. Okay, I'm not sure why they didn't give you a space for them. If the... Oh wait, there is space for it. Okay, it's on the back. It's on page 30. So here's a good place. Right below where it says no solution, I want you to write, or in that box you can write this information. Okay. If the isolated absolute value equation is equal to 0, then it's only going to have one solution, right? Because let's think about that. If I have x plus 2 inside the absolute value bars equals 0, right? There's only one thing I can put in there that's going to make the absolute value actually equal 0, and that's x equals negative 2. There is no or. There's nothing else that can fit there. That's an example of when it has one solution. So I think I might have said that goes with the no solution. This is one solution. Okay, when it's equal to 0, it has one solution. I put that with that box there in the middle on page 30. Okay. If the isolated absolute value equation is equal to a negative number, it has no solution because absolute values can't be negative. Right? So there's no way, right, for example, that the absolute value of x plus 4 could equal negative 2 because there's nothing that I can plug in for x that when I would take the absolute value out. Did you know that you could get extra announcements from school when I'm recording? Pretty cool, huh? All right, so let's continue. What could I put in there? Some of you are thinking, well, you could put in negative 6. It would work. Negative 6 plus 4 is negative 2. Well, you're right that it is, but then, right, after I plug in negative 6, right, and I get the absolute value of negative 2, what does it come out to be? Oh, positive 2, right? So this has no solution. There's nothing I can plug in for x that would make, right, the absolute value turn out to be negative because absolute values are always positive. Okay. So here's a couple. Let's just make sure everybody understands when it's a little bit more complicated. Go ahead and squish this in somewhere. Get binder paper if you need to. Right? I still get the absolute value part all by itself. Okay. So the 8's gone. And then look what happens. 0 equals the absolute value of x plus 2. Right? So once again, right, I just have one equation. 0 equals x plus 2. So x equals negative 2. Okay? And you can still put that in braces all by itself. You should be banking that this is probably going to be one with no solution because we already did one with one solution. So we get the absolute value part all by itself. The absolute value of x plus 4 equals negative 3. Right? And you don't have to go any further because as soon as you see this negative, you can stop. There is nothing that you can plug in for x. Right? Sometimes for no solution, people also do an empty set. They would put nothing inside of it. And that's it for this lesson. Hope you had fun. It's the end of chapter 2.